Hello, today we're going to be going over how to create a beam model, I believe, in ANSYS. So that's going to involve opening a workbench, choosing a static structural project out of the toolbox, dragging it into the project schematic, and opening the geometry. Once you've opened up the geometry, we're going to create the structure. So we're going to create that geometry. First step is going to involve checking layout sketch. Is going to be somewhere here. And then you're going to navigate to the space claim options to change the unit from metric to imperial, and you're going to change the length from like inches to feet. Okay. And then it's going to leave you here. Let me see if I can demo it. Let me see. Let's create another one. Okay, so to create the design, we're gonna select this plane here, our XY plane. Gonna turn it. We're gonna choose lines, and we're gonna say, see layout sketches highlighted. We've already got the units changed. So it's gonna be 12. Okay, we don't have the units changed. This is why it's important to change your units. And I can't do this because I'm realizing it won't let me do the demo while I'm recording my screen. But you're gonna change the units as I previously indicated. So this is 12 by 18 by 18. And then the next step involves actually creating the beam. So you can sort of see it right now. But we're gonna navigate to standard library, AISC, navigate to W18107. W18106, I believe, my bad, 106. Right here, I'm gonna right click that, highlight it and import it, and then it's gonna pop up here. You're gonna select it, you're gonna choose, click create, and then you are going to, that's how we're gonna like superimpose it onto this geometry that we've already built out. Okay, now Professor Shi, you may be familiar with the fact that like my this part acts funny, but so when you do this, it's initially gonna like pop up as a wire beam seen here. You're gonna navigate to display and change it to solid beam so that we can change the orientation. So we're gonna change the orientation. You see this blue arrow, you're just gonna double click it, and it's gonna like change the orientation of the beam so that it's on the stronger side. So we're gonna do that for each of them. It's actually gonna end up this way. Okay, I don't know why. So it's gonna end up the way that I had it previously, but that's just a tutorial on how to do that. So you're gonna rotate all three of them so that they are the long way. I think I just rotated them back. But okay, and then once you have rotated your beams, you are going to navigate to a workbench, and you're gonna share everything. So you're just gonna click share and then check to complete it so that all these joints are connected. And then I think that's the last step in this geometry. It's pretty straightforward. The next step is then to open up the modeling software. So you're gonna edit it, and it's gonna bring us here. And initially, when you open it up, it's gonna show you this. So this is your model. It's the geometry, and here's the beam system. Let me turn off the cross section. So here's the beam system. And then we're gonna make a couple of modifications just to make sure that it fits the constraints of the system that we were given. So we are going to We're going to mesh it, so we're going to select mesh, and then we're going to select sizing, and this is sort of what we're going to do. So we're going to highlight 3 of them. You can do this by clicking box select and specifically choosing edges. And then you're going to highlight everything into a big box, and that will be your geometry. Like that would be the 3 edges for your geometry, and you're going to make the element size 0.5. And then alright, now we're going to add the constraints for the system. So first one is simply supported. You can just select that and choose this edge. So you're actually going to choose like this and choose this point right here, this vertex for where you're going to place it. And then for your fixed support, we're going to do something similar. Navigate to fixed, choose this vertex right here. For the line pressure, we are going to select edge, and we're going to select this edge right here, and then we are going to define it not by the vector but by the components. So we're going to make the x component 1200 newtons per meter. And then for the line pressure here on the top, we are going to do the same thing. So we're going to select line pressure. We're going to select the edge, so this one right here. We're going to change it from vertex to components, and then we're going to make, this is the y component, so we're going to make it negative 1600 newtons per meter. And that's how we add the constraints for our system. And then, so that's how we add the loads to each of the edges or each of the sides. And then one way, we're going to sort of like make it hinged. So we're going to make a hinge somewhere around here. And we're going to do that by navigating to model, inserting, and then choosing to create and when we like select that, you should be able to see connections. I'm not too sure why it's not popping up, but we have previously made it. So in connections, we're gonna choose an end release, which is found here. And then for the end release, we're gonna have to like be very intentional. So we're gonna click this, make an edge, select this edge, and then make that our edge geometry. For the vertex, we're gonna select the vertex, click this vertex, and make that our vertex geometry. And then that's it. That's how we make that hinge. And all that's remaining now is actually to solve it. So we're gonna apply like a directional deformation. So directional deformation, normal stress, axial force, a bending moment, and even a shear moment diagram. And then we are going to create reaction forces. So I'll show how to create the reaction forces first. So for the simply supported, you're just going to drag it into solution, and that will create reaction force number 1. So as you can see, that's where simply supported is. And then for our fixed support, we can do the same thing, drag it into solution, and that's where you're going to see that reaction force for that. The only other thing that we really have to figure out is that total shear moment diagram. So we're going to do this by, I want to say, hold up 1 second. Okay, and to identify the total shear moment diagram, we're going to select shear moment diagram. And when you select it, you're actually going to see like, it's going to show you that the path is like, there's nothing in the path. So we're going to do this. We are going to go to model, and select insert, and then we are going to create a path. Let me see. Yeah, it should be in construction geometry. Yeah, so construction geometry, and then you make that path, and then it'll bring you here. And then to actually select the path, you're going to get the option for choosing your geometry. You're going to select edge. You can either box select it, or you can just like highlight them all. And then You get 3 edges and make those your chosen geometries. And then we'll be able to see the total shear moment diagram by navigating back to there and selecting the path to be path, and then that's it. That's all that's remaining. I think there's like, oh, one thing you have to do, he said in the tutorial, was like go to beam section results and solution and just change it from no to yes. Something about it'll show the stress. I'm not too sure. Okay, and then these are the final results. So here's our directional deformation, our normal stress, our axial force, total bending moment, total shear moment diagram seen here, and then our force reactions. That's it. Thank you.